Okay, Arnold, can you unmute? Yes, Arnold. Hello, Arnold. Okay, let me pick Rahama. Rahama, unmute.
Yes.
Can you pray for us?
Okay. Let's humble ourselves for a prayer. Can you hear me?
Yes, we can hear you. We can hear you.
Okay. Heavenly Father, I want to thank you for the gift of life. I want to thank you for this day. I want to thank you for this lesson that we are about to have. Lord, help us to understand everything that our teacher is going to teach us, and help us to analyze everything that we can be able to get the concepts. Oh Lord, also pray for those victims of COVID-19. Also pray for those people who are not okay, so they can be fine. In God's name I've prayed.
Amen. Thank you so much for praying for the sick and for praying for everyone here. I welcome you once again to today's session. As you're well aware, the week that just ended, that's last week, we had a simple assessment on what we had so far covered. I've finished marking your papers, and results show that we are concentrating, we are doing the work. I'm happy with my form 5s. I'm so happy because what I've seen indicates that we are doing some serious work out there. It is my appeal to those who did not perform well. I know paper could have caught you offside, that in our next assessment, make sure you go back with something in the pocket. Can I see by show of hands, those who have seen their results already? You can raise up your hand. Those who have already seen the results. Yes, Lavins has seen, Benjamin has seen, Alicia has seen already. Tekno F has seen, those who have seen their results. Yeah, good number of you have seen the results already. And as I told you, the best, of course, will walk away with the bottle of soda in today's lesson. So when you tell that you're the best, you walk away with your bottle of soda without any problem. Okay, Bright Rahama says, I did not receive mine. Bright, I don't know the time you submitted, I don't know. But if you submitted earlier, I think I've marked. If you have not seen, then I can take you through where our results are. Allow me to share my screen with you. Okay, for those who have not seen the marks, I'm taking you to where the marks are. You just go to your Google Classroom. My Google Classroom is here. Rama, can you see on my screen?
Yes, I can see.
Okay, please. So you just go on your Google Classroom. Mine is there. Okay. Then we are in Senior 5. This is the one. Then you'll go to the classwork. There's stream classwork and marks. I can go to classwork. Then I look for assessment. Senior 5, end of assessment is here. You can see that, let me go to view first. Let me view the assignment. Let me view the assignment. Then you can see that out of 147 who are in our class, actually, 15 have been marked. And out of those 15, there were those who had handed in their marks. So far, nobody has handed in the marks. I've marked 15 already out of 147. So the turn up was not very good. I don't know this number. I don't know 140. I don't know where they are coming from, but they are the members we have in our class. So when you scroll down, you will see marks down here. Missing those, and there are those who have not submitted. You see marks down here. Okay, marks starts from here. Kakunda Precious, she has 60. Amelia Justin, she did not submit, that's why you see a blank space. Andrew J. Cabezon got 80%, though he submitted late. Do you see this one is submitted late? Okay, I can see. Then Courtney got 88%. Derek Jaden got 75%, though done late. Intungu Goddess got 68%. Jesse Atwend 85%. Then Jubek Steven, he took it all, 100%, all of it. Some people are dangerous, I'm telling you.
Sure.
Yes. Yeah, Councilman Monica, 95%. Joy Lovins, you are there. You are going to tell me what happened. I don't see your marks here. You are around. And then we have Martin Seko, 80%. Mugisa Ando, 95%. Paul Wamuza, 90%. Rina Agaba, 80%. Then Shivan, I don't know what happened here. You don't have the mark. Now, when you follow very well, you realize that the performance was not bad, was too good. Jubek Steven, are you there? Because according to our performance, Jubek Steven is the best with 90%. Jubek Steven, can you raise up your hand if you're around? Jubek Steven seems he's not around. So he's the best. He's the one taking the bottle of soda. I'm going to keep it for him. You never know, you may claim it in the next lesson. But if in the next lesson he does not take it, I will give it to some other person, and that will become Sime Monica with 95%. Plus Ando, 95. So basically, that's how we performed. Aldo, I see you around. Ando, how are you? Ando, you can unmute. Ando, okay. I see Joy Lovins with hands up. Joy Lovins, you can tell me.
Yes, sir. I actually received my marks today on my paper, so I don't know why my name is not having my marks there.
You receive on the paper?
Yes, I saw my marks on my question paper.
Oh, let me check. It could be the system never saved it. Just
and so I think I was supposed to be the best. Seriously, because I failed only one, and you gave me 88.
You failed only one?
Yes.
Let me check for you. I think you're supposed to be the best.
I'm supposed to be the best.
Joy Marvin. Oh. I don't see anything here.
It must be there somewhere.
It's okay. Because Joy Marvins is here. I see Joy Marvins.
It's Lavins.
Yeah, Lavins.
Yes.
Lavins is here. Joy Lavins, history, physics is here. And I see it is marked.
Yes, it was marked and it has
It is
the
having
marks.
88. I think
But I thought one.
something went wrong. It is here, it is 88%. Let me return it to you. It is saving. Good. You now have your marks, Lavins. So you're saying you are supposed to be the best? Lavins?
Yes.
You failed only one thing and
Yes, I felt the one I never knew. As in, it was number 2.
number 2.
Yes, only that one. The definition. That
Okay.
means I'm supposed to get 99.
Okay. It's fine, but you find that the paper was out of something. It was not out of 100. So if you fail one, you might find that you miss like around 5 marks.
Oh,
Yeah, that will be the problem. Because
okay.
I see here is your paper. Your pod matter here seriously. Okay, good. So that is briefly how we performed in our paper, in our last paper. Sir, I received my marks. Good. I see you are still telling me in the morning, actually. Me too, I failed one. Bombale Benjamin is saying that he also failed one, but I don't know how many you got. But generally, I'm just happy because of the performance, okay? If we remain like this, I think by the end of this year, we shall be very, very far with the physics. Today, we are going to do some correction for those few numbers which we failed. And then in our next lesson, we shall resume back and we see thermocouple. After thermocouple, we shall see constant volume gas thermometer, constant pressure gas thermometer, optical pyrometers. Before we enter into what? Before we enter into heat capacities. And the program is there. We shall also organize for you physics paper 2 so that you can also discuss physics paper 2 because we want us to balance the board. I just appeal to you that you should keep calm, keep on track, keep revising. I'm very sure at last we are going to win this battle. And at least I'm somehow convinced that we are at the verge of winning it. Isn't somebody seeing that? We are about to win this battle. Much as COVID is disturbing us, but we are looking for all the possible solutions. So today, let's make some corrections on the numbers, which I want us to participate in it. It is senior 5, physics. Unless there's any concern, is there anybody who has something wants to say, or so that at least?
Yes, I have something to say.
Yes, Bright Rahama.
Teacher, me, I'm not contented because I was among the first people to hand in, yet I'm not seeing anything like marks on my work because I really handed in the morning when the paper was sent. Yes, and I've not received my results yet.
And I don't know for do you see on my screen, Rahama?
I can see.
Yeah, do you see senior 5 physics end of month assessment?
Yes, I can also see that.
If I go to students' work, okay? It shows me that Nobody has handed in. Those who have handed in, they are 15 and they're already marked, okay?
Yes.
Now, when I tapped on the marked ones, you see there's a Gaba, Rina, this one, Jessica, okay? And let me see, up to here. Do you see your name? Martin, Paul, Kansime, Amelia, Justin, and what? Do you see your name anywhere? Rahama?
No, I can't see it. That's why I'm wondering. I can't see it.
Yeah,
Yet
now,
all the assignments I've been handing in and I've been receiving my marks for all the assignments, but this assessment I didn't receive anything.
yeah, I think there could be a problem in like how you handed in. That could be a problem. You are Rahama, not so?
Yes, it showed turned in actually. I scanned it and I also turned it in.
Let me see. Rahama. Something could have gone wrong during the process of you handing in. That could be the reason why I have not received. Rahama. Bright. You're registered by its name Rahama Bright or Bright Rahama?
It's bright first.
Bright, eh?
Yes.
So I've sorted the names. Bright, I see Bright Nancy, I see Bright Crispus. Rahama, are you in senior 5?
Yes, I'm in senior 5.
I mean, did you register in you've been doing and you've been submitting for the other classes, eh?
Yes, and also physics. I've so far received all the assignments which you have sent us, and I received my marks very well. But this time around, I didn't get anything.
Because I'm even not seeing your name on the list here. Mr. Bernard? Hello, Mr. Bernard? I don't know whether Bernard is around. Mr. Bernard?
Yes, please.
Brett Rahama, I don't know whether you can see my screen. Our marks are not there, and also I'm trying to search for her name and I'm not seeing it anywhere.
So did she join the Google Classroom?
She's telling me that she joined, yeah.
And did she do the exam?
Yeah, that she did and submitted.
But it should appear there.
Rahama, we're going to sort this one after, okay? Rahama?
Yes.
We are going to sort this one, or I can give you another option, okay? I don't know whether you have kept the work. Have you kept the work?
Yeah, I think I kept the work.
Yeah, now what you're going to do, right after this lesson, scan again and send, okay?
Actually, I'm seeing in the chat, Benjamin is saying maybe you handed in wrong procedures. Maybe she's using another person's Google account, something like that.
Could be.
I'm using my personal Google account actually.
Rahama, I'm giving you another chance, okay? Scan again and send. Is that fine? Is that okay, Rahama?
Yeah, though I'm not happy at all.
I'm very sorry
But
for
I'll
that.
do it.
I'm very sorry for sure. I'm very sorry. See, this is the. I'm very sorry for that. This is the internet stuff, and so if I don't receive, I can't lie that I received when I did not see it. Something could have gone wrong somewhere. Please, my sister, try again so that at least I see your work and I mark it. Let's start the correction right away. Thank you so much. Unless somebody's having another concern again, I don't see any hands up. So that means that everybody's okay now. Number one, define the term thermometric properties, giving any two examples. Now, all of us, almost all of us, were defining thermometric property. But the problem came in giving the examples. Please don't forget, I told you, if you're to give the examples, you give the thermometric property and the thermometer in which it is used. Is that okay? You give the thermometric property plus the thermometer where it is what? Where it is used. Most of us were giving thermometric property only without stating the thermometer in which that thermometric property is used. It's not good. Let's state, that's why most of us, I mean, some people fail this number one. But let's state the thermometric property and the thermometer in which it is used. Let's start by defining thermometric property. Bob Muller. Bob? Bob? Hello, Bob? Okay, we can define for us. You can raise up your hand. Yes, Bob. Bob, yes, I see Bob.
A thermometric property is a physical quantity which varies linearly and continuously with change in temperature.
Very good. Bob, go to campus, man, okay? Very, very good. Thermometric properties are physical properties which vary linearly and continuously with the change in temperature. Good, good, good. Examples, Amelia? Justin? Amenlai? Yes, Justin?
Yes, I'm called Amanile.
Amanile.
Yes.
You're going to be a great engineer, man. That name is for engineers.
Obvious.
Okay, Justin, can you give us some of the examples of thermometric properties?
Yes. Length
Yes.
of a liquid column in liquid glass thermometer.
Very good. Length of the liquid column in a liquid glass thermometer. That's how I wanted you to state it. Very good. Add another one.
Electrical resistance of a platinum wire thermometer.
Very good. Electrical resistance in platinum resistance thermometer. Thank you so much. Good. Let me hear from my sister Priscilla Magoba. Yes, Priscilla.
The volume of a fixed mass of a gas at constant pressure.
Very good. A volume of a fixed mass of a gas in constant pressure gas thermometer. Then, do you want to add another one?
Let me add one.
Okay.
Thermocouple.
Okay. Variation of EMF in a thermocouple. Very good. Very good. Thank you so much. Then, Justin, it seems, oh, you forgot to put your hands. Okay, good. So those are the thermometric properties. Length of a liquid in a liquid gas, liquid glass thermometer, variation of EMF in a thermocouple, variation of electrical resistance in platinum resistance thermometer, variation of wavelength of electromagnetic radiation in optical pyrometers, variation of fixed mass of a gas mean pressure of fixed mass of a gas in pressure of fixed mass of a gas in constant volume gas thermometer and volume of fixed mass of a gas in constant pressure gas thermometer. Those are the ones. What are the 3 qualities of a good thermometric properties? Good, Benjamin?
It should vary continuously with changing temperature.
Very good. Druslack. This name also. I think this is also another engineer. Druslack. 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 Okay, can't talk.
It's be accurately measurable over a wide range of temperature.
Should be accurately measurable over a wide range of temperature. Good. Joan?
And then
you want to add another one?
Yes, I want to complete the other one that the previous guy gave, but he left it hanging.
You can complete it?
It vary linearly, continuously, and uniformly with temperature.
Good. Linearly, continuously, and uniformly. Oh, you both have matter. Matter is just overflooding, for sure, I see. Yes, John?
It should be sensitive to temperature change.
For any small change in temperature, it must be in position to detect it, okay? So it has to be sensitive. So those are the thermometric thermometric properties. Good. Benjamin, do you have another one?
No, I just have a question.
Yes, please, go on.
I thought these are different 2 qualities of continuously and linearly, isn't it?
Continuously and linearly, and when they say linearly and continuously,
they're not 2 different qualities.
Then uniformly is also a property itself. Because when you talk of continuously and linearly, uniformly can also come in, but you're saying that when you talk of uniformly, it can also be a point on itself. Linearly and continuously can stand as 1 point, then uniformly can also stand as the other. But if you want to make it sweeter, there's no problem. You can say uniformly, continuously, and linearly, because they're almost there. Good, thank you. You can lower your hand. Good. Let's go to definition number part C. Define Celsius scale. Joy Marvin.
Celsius scale is the temperature scale. Are you getting me?
Yes, we are getting you.
Yes, it's the temperature scale that uses ice point as its low fixed point and steam point as the fixed point.
Oh, good. Is a scale which uses ice points as its upper fixed point, lower fixed point, and steam point as its lower fixed point. Good. Thank you. Drew's Luck wants to add something.
Teacher, I was asking, what if you say a Celsius temperature scale is that which measures degrees in centigrade and uses the lower fixed point and upper fixed point?
Okay. Now we are elaborating. It measures in centigrade. And because the most important part is the other one, okay? And uses the ice point as the lower fixed point and steam point as the upper fixed point. Yeah. Because the most important, what we look for is the other one. Ice point as the lower fixed point, steam point as the upper fixed what? Fixed point. Automatically, there is no another scale which does that. It is only Celsius scale. Thank you so much. This luck.
It's Drusilla.
It's Drusilla. I see. Your name is very good and very nice, very interesting. I wish one day we can be in a seminar together. I will be very grateful to have you physically. With reference, very many people fail with this. With reference to liquid in a glass thermometer, describe the steps taken when establishing a Celsius scale. With reference to liquid in a glass thermometer, can you describe the steps taken when establishing the Celsius scale? Who can describe for us that? But before you start describing, yes, I'm going to pick Benjamin. Before you start describing, please, they say with reference to liquid in a glass thermometer. That means that the thermometric property has already been chosen for you. So the other part which you say, please choose the thermometric property X. No, when we start like that, you will have failed. Because the other one was a general one. Choose a thermometric property X. It was a general one because we didn't know the thermometric property. But here, we're talking about liquid in a glass thermometer. So liquid in a glass thermometer uses which thermometric property? The length of the thermometric property. The length of the liquid. Yes, Benjamin. Benjamin, can you come back? Yes, my brother Benjamin. Hello, Benjamin. Okay, I see you here. I see you. It's okay now. Can you unmute? Hello, Benjamin. Okay, let me give the chance to some other person. Who is there? You can raise your hand. I take us through. Hello. Okay, good. I see. iPhone, tell me your name so that I rename you. Tell me your name. Tell me your name. What is your name? Okay, has gone. iPhone, what is your name? Okay, fine. Your network is not clear. Good. So Joyce Lovins. Joy Lovins. Joy Lovins. Okay, we can do this together now. Hope you can still hear me well. We are describing the steps which are taken in determining in establishing the Celsius scale, but using.
Excuse me, sir.
Yes, please. Hello, go on.
Yes, are you getting me?
Yes, I can get you. Yes, Joy Lovins, go on.
Okay, try.
Sorry?
I'm just trying.
Okay, try, go on.
Okay, the bulb is first put in ice.
The bulb is first put in ice. Yes, you're correct.
Okay, am I on the same page with you?
Yes. It seems network is disturbing you.
And we find the length of a mercury column in a capillary tube.
That is That is the statement I was waiting for. The length of the mercury column in the capillary tube, and you label it to be what?
Or not, right? Or
Very
zero.
good. Uh-huh.
Then the bulb is again put in steam.
Very good.
And we find the length of a mercury column in a capillary tube, and we label it L100.
Very good. Uh-huh.
So the bulb is then is like brought in contact with the body of unknown temperature.
Uh-huh.
Theta.
Uh-huh.
Right?
Then what do you do next?
Then we put the formula, I think.
Very good. Then the value of theta is calculated from theta equals to
L theta minus L naught over L100 minus L naught
minus L naught
times 100 degrees Celsius.
Times 100. Thank you, thank you, thank you. Thank you so much. You are too good. Okay. Actually, what I was waiting for, I was waiting to hear L. That's the only thing I was waiting for, L. Because the thermometric property they have given you already, liquid in a glass thermometer. So it is expected to use the thermometric property, which is length of the mercury thread. So in the other description, I think that's why most of us feared. In our description, we said that the thermometric property X is chosen. After choosing, you measure the value of the thermometric property X at ice point, and you label it to be X naught. You measure the value of the thermometric property X at 100 degrees Celsius at steam point, and you label it to be X 100. Then you measure the thermometric property at unknown temperature, theta, and you label it to be X theta. Then from there, we plotted a graph of thermometric property against temperature. We obtained the slope. From there, we found out that theta is calculated from L theta minus X 100, minus X naught over X 100 minus X naught times 100 degrees Celsius. That was the general description. But if I tell you with reference to platinum, today I've brought for you with reference to liquid in a glass thermometer. Tomorrow, I'll bring for you with reference to platinum resistant thermometer. Describe the steps taken when establishing a Celsius scale. I don't expect you to use the length. No. I expect you to say the resistance of the platinum resistant thermometer is measured at steam point, at ice point, and recorded as R naught. Then the resistance of platinum resistant thermometer is then measured at steam point and recorded as R 100. The resistance is then recorded at unknown temperature as R theta. The value of theta is then calculated from theta equals to R theta minus R naught over R 100 minus R naught times 100 degrees Celsius. Is that okay, everyone? Is it fine? Let me know. You can just use a signal or you can use the chat. Please, is it okay?
It's fine.
It's fine. Good. Good. I see, yes, I see signals that is fine. Monica says teacher is very okay. I see some hands up. Kim, can you tell us what you want to say?
To repeat for me that formula, I didn't get it properly.
Hey, the formula.
Yes.
Okay. The formula came from a derivation, but I'll just quote it here. But it is theta, okay, equals to L theta, where L is the length of the mercury column at the unknown temperature theta. Is that okay, Kim? Minus L naught divided by L 100 then minus L naught, the whole thing we multiply by 100 degrees Celsius. Is that okay, Kim? Hello, Kim? Hello, Kim? Is it fine? Hello? Kim? Hello, Kim? Okay, I can't hear you. Okay, good. So that is that briefly. Okay, I see Titus is saying it's fine. Good, Titus. Let's go to the next number. Aha! This one. Explain why two different thermometers give different readings for the same temperature. Aha! That part, almost everyone passed it. Bright Rahama, your hand is up. Bright Rahama.
Yes.
I see your hands up. You want to answer that question?
Yes.
Go on.
This is because temperatures use different thermometric properties, which have different thermometric properties that vary differently with changing temperature.
It's because thermometers have different thermometers have different thermometric properties which vary differently with the change in temperature. But they have to agree a fixed point. Good, good, good. So that is why.
Sir, and the other thing is.
Yes.
So the other thing is that I've sorted out my problem. I've been able to see my marks, and you marked.
You have seen your marks, eh?
Yeah, you marked, and I got 100 by the way.
Are you sure?
Yes, I'm very sure. I can screenshot the end of the lesson.
I'm very happy for you. If you have 100, you have a bottle of soda from me. Okay? I need to just confirm it. You give me the MTN number, you get your 100 without any problem.
Okay.
Got it. I will check your marks. When I see 100, you will get your soda without any problem. Because you are two people now with 100 then. Hey, that is good. Very good. Okay, let's move on. So we're saying that different thermometric properties vary differently with the change in temperature. And so we don't expect them to give the same reading even for the same temperature. Like if I talk about the length of mercury thread, the way the length of mercury varies with the temperature is quite different from the way the resistance of platinum resistant thermometer varies with the temperature. And so if you use platinum resistant thermometer to measure the temperature of the body, and you use mercury thread thermometer to measure the temperature of the body, you will get totally two different values. When we go ahead, not very far, we are even going to see that Rahama, do you hear me? Rahama?
Yes.
you are requested to rejoin the senior 5 class, okay?
Okay, but I joined.
Because I don't see your papers. I don't see your papers. So what you are going to do?
Marked.
Yeah, I marked. Yes, I marked. But make sure you rejoin, okay?
I have rejoined.
For you, just do as we have said. Your network is not clear.
Again, using the. Okay, I'm going to rejoin.
Yeah, you rejoin so that I'll be in position to see your marks. Is that okay? Yeah, it is right from my admin, Mr. Bernard. Make sure you rejoin so that I see your marks, because I was not able to see it. So I was telling you that two different thermometric properties do not agree even when they're measuring the same temperature. You will also see when we start a discussion on modern physics, you will see that even not only thermometer, even scientists who are not agreeing on some terms. Like there's a scientist who is called Bohr and Rutherford. Those two scientists did their experiment on an atom. And the two came up with two different findings. Now, one started saying that, you, Mr. Bohr, you have found out this, and this. Can you explain why this one happens, if that is true? So some of them were not able to explain their findings. So it became their failure. That's why we have failures of Bohr, we have failures of Rutherford. So even human beings, even scientists did not agree on some other things. Even up to now in real life, we don't agree. That is the same way when it comes to thermometers. They also don't agree. The way you understand things is quite different from the way I do. So I can agree, but for you can disagree. Or you can agree and you find like me, I'm disagreeing. That's the same story with the thermometers. Two different thermometers can never give you the same reading, never, unless at a fixed point. And we have given the reason because they vary, the thermometric properties vary differently with change in temperature. Good, fixed point. You will forgive me when you don't say under specific conditions, or when you use which type of words in physics. I cannot give you that mark. So there are those who use very many sweet, nice words to convince me. Yes, I was convinced, but I was looking for under specific conditions. If it is not there, then you miss out the mark. Good. Who can define for us fixed points, giving two examples of each? Hello, 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 hello. But you wait, you people, you first wait. There are some people who have never talked in my class. For sure. If you cannot talk in teachers Daniel's class, if you cannot talk in my class, in whose class can you talk in? I'm asking just, where can you talk now if you can't talk in my class? For sure, no. Those who can't talk in my class, for sure, no, 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 no. I see you, you are there. You're very quiet down there. You see Trace, you used to be very active. I don't know what happened this time round. You see Priscilla, you see Pacific, you see Alicia, you see Johan, you see Frank, you see Sheki. For sure, you people, talk in my class, please. Okay. Yes, Titus. Hello, Titus. Hello, Titus.
A fixed point is a constant temperature at which the physics of water is expected to change under standard conditions.
Water is expected to change under standard conditions. Okay, good, thank you. Let's hear from John. John?
Fixed points are temperatures at which a substance changes state under specific conditions.
Very good, very good, very good, good. Let me hear from Drusla. Today, you're very active, Drusla. I like that.
Okay, teacher, you discouraged me, but let me give you my answer.
How did I discourage you? Sorry?
Actually, teacher, you first listen to me first.
Okay.
Okay. Fixed point is a constant temperature at which a physical state of pure water is expected to change at 760 milligrams of mercury. And for example,
yes,
760 mmHg.
Okay, good. That is millimeters of mercury.
Yes, and for example, we have 0 degrees Celsius and 100 degrees Celsius.
Oh, good. But for sure, let me know how I discourage you, my sister.
Okay, teacher, you are like, yes. If your answer does not have our under specific conditions, then it's not correct.
Okay, the fact that you said it is the temperature, is the temperature at which physical change takes place at atmospheric pressure of 760 millimeters of mercury. That's already the specific condition I'm talking about, okay?
Okay, teacher.
Because some people say under standard atmospheric pressure, okay? A temperature at which physical change takes place under standard atmospheric pressure. And what is the standard atmospheric pressure in this case? Standard atmospheric pressure is 76 centimeters of mercury or that. Yes, Priscilla. Yes, I see your hands up. Your network, Priscilla. Go ahead.
Can you hear me now?
Yeah, at least you're better. You try. Oh, Priscilla, we can't hear you for sure. Network. We can't hear you. Justin Amanel is saying, ha ha ha. And then Alicia is saying, teacher, the reason why I'm not participating is because our houses are loud. Alicia, be serious. Can we test and we see whether your house is very loud? Let us test and we hear. Alicia Mbabazi. Alicia, unmute and you say hi to us. Alicia, unmute.
Hello.
Hello, how are you, Alicia?
I'm okay, sir.
Can't you see? Your house is not very loud.
It's because I've told them to keep quiet.
Well, you have told them to keep quiet, Wama.
Yes, that's why.
Okay, Kale, but are you getting everything?
Yes, I am.
Okay, that's good. That is good. That is good. Thank you.
Okay. Okay, sir. First, sir, let me ask.
Yes.
Okay. My answer is like this.
Yes.
A fixed point is the temperature at which a substance changes state under specific conditions like ice point and steam point.
Very good. Very good. Very good. Very good. Very good. A specific temperature under which a substance changes state.
Yes.
Under specific conditions. And there are two types of fixed points. Our time is up almost. There are two types. We have upper fixed point and lower fixed point. We are going to define only the triple point of water, and then we stop. Or I give that chance to who? Whom should I give this chance for sure? Whom should I give this chance for sure? People are struggling for the chance. For sure, my sister Priscilla. We did not hear you in the first place. Yes, Priscilla?
All right. Yes, triple point of water is the unit temperature at which pure ice and pure water and pure water can exist together in equilibrium.
Very good. At standard atmospheric pressure and pressure at standard atmospheric pressure, don't forget that. A temperature at which pure ice, pure water, and pure vapor can exist in equilibrium at standard atmospheric pressure. Yes, Titus? Titus?
I have the same answer.
Okay, good, brother. Good. You people, for sure, the lesson was supposed to continue. Unfortunately, the time has refused. Time, banange. Time has refused. So, allow me, if there's no question, Joy Marvin, do you have any question? Joy Marvin?
Yes, sir. Like next time, shall we use the time for low points?
Sorry?
Okay, we only have a definition for fixed point, but I don't know that one of low point.
Lower fixed point and upper fixed point.
I think so, yeah.
We define upper fixed point. We said upper fixed point. We said upper fixed point is the temperature of pure boiling water at standard atmospheric pressure. Then lower fixed point, we said, is the temperature of pure melting ice at standard atmospheric pressure. We have it in our notes, okay?
Okay.
Okay, you can go and check in our notes. Yes, I'm giving only one chance to Justin. Justin, do you have a question?
Yes, it's not like a question, but just like a proposal.
Yes, please, it's most welcome.
I was just thinking that like when we resume the normal lessons,
yes,
is it possible like you send for us the notes, we copy early so that we can be able to catch up with this 1 hour time? We have a lot.
Yeah, actually, that is even the best option, okay? I can send you the all notes, okay?
Yeah.
You copy it. When I come only to explain most of the things which are already in the work, okay?
Yes, sir.
That's a good proposal that has been taken into consideration. Yes, Benjamin. Benjamin?
Sir, by the time you were explaining the other experiment, I wasn't around. So I wanted at least at the beginning of the next lesson next week to repeat it for me.
Okay, please. I'll do that for you, okay? Kale, thank you so much, everyone, for attending. I'm so happy that you have attended and you have made it a point to be here. Let's end here. I thank everyone. Let me invite Mr. Bernard maybe to say a remark, to give the final remark as we end this meeting. Yes, Mr. Bernard. Hello, Mr. Bernard.
Class has ended. Well done for reading it.
Thank you.
Have a great evening.
Okay, please. Bye, everyone. See you. Thank you.